Hello, welcome back to Learn Physics. In today's topic, we are going to discuss about the gravitation chapter. So in last video and last to last video also, I explained about the theory portion and some numerical part also we did. Okay, so today I came with the exercise portion, that is NCERT exemplar questions I am discussing today. Okay, so first question is, what is the source of centripetal force that a planet requires to revolve around the sun? Okay, so in necessary centripetal force will be provided by the sun. From where that sun is getting that necessary centripetal force? See, the sun will be getting the centripetal force because of the gravitational force. Gravitational force which is given between sun and the planet. Between sun and planet, a gravitational force is there. That gravitational force will be given by the acceleration. Isn't it? Acceleration due to gravity between the of the sun will there is a force of attraction between the sun and the planet. That acceleration, force is there, acceleration also there, right? So that acceleration will be helping to give this necessary centripetal force. Okay, so centripetal force is given by the acceleration which is provided due to the gravitational force. Okay, so that will be helping so centripetal acceleration will be acting on it, and which will be helping for the centripetal force. Okay, so acceleration will be giving the centripetal force. Centripetal acceleration is there. That acceleration will be helping to give the centripetal force. And the next one is, on what factors does that force depends? So force between these two objects, that is sun and the planet, is depending directly on we know as per Newton's law of gravitation, force is equal to Gm1 m2 by r square. So here which are the two masses? One is sun and the planet. So mass of sun and next is mass of planet, and the third one is inversely proportional to the square of distance between sun and planet. Okay, distance between the sun and planet. Okay, so these are the factors which depends on the gravitational force. That means depending on the centripetal force. Okay, next one. On earth, the stone is thrown from a height in a direction parallel to earth's surface, while another stone is simultaneously dropped from the same height. Which stone would reach the ground first and why? Okay, so if we are throwing a stone like this, what will happen when when the velocity becomes zero? That time it starts to fall down, isn't it? Second question, see, if I am throwing a stone vertically like this, after some time it will fall down, right? So if I am dropping a stone at that time, which stone will be reaching first? Because the time required to reach the ground will be depending on the vertical height. It is depending only on the vertical height. So here for the first case, see, S is equal to ut plus half at square. If I am taking this formula, what is the initial velocity? 0. Then what will be the time acting on it? 2s divided by a. What is a here? It is acceleration due to gravity. So t will be equal to root of 2s by g. It is depending on the vertical height. Okay, so even if it is throwing that, when it is throwing like this, it is how much of a velocity is there. When till velocity become equal to 0, it will be moving parallelly. After that it starts to fall down. Okay, in higher classes means for this we will be using projectile motion, like that one motion is there. Okay, that one we will use. But here for 9th standard students that is not required. So you can take it in this way. Okay, so this is the time required. Here also the same way we can do. S is equal to ut plus half at square. S is the distance, initial velocity is 0, half gt square. So we will get t as root of 2s by g. So when the object is falling down, it is depending on the time required depends only on the vertical height. Okay, so both the stones will be reaching the earth at the same time. Okay, so this is the why. Why means this is the explanation for that. Okay, clear? So the next one is, suppose the gravity of the earth suddenly becomes 0, then in which direction will the moon begin to move if no other celestial body affects it? See, if suddenly the gravity of earth is equal to 0, what will happen? If suddenly, in which direction will the moon begin to move? See, if no other forces are acting. So moon and earth is having a force of attraction, but that gravitational forces suddenly it is coming to 0. That means suddenly the force is not there. See, suppose, leave that portion. Suppose I am taking a string with a stone at one end and I am rotating the string like this. What will happen? This stone also rotating in the circular manner. Suddenly if I am leaving the string, what will happen? The stone, in which direction it will be moving? It will be moving along the tangent of the circular path. Okay. It will be, so if this is the circular path, I am leaving the force at this point P, then it will start moving in the tangent to that circular path. Suppose if I am leaving the stone at this point P dash, it will move in this tangential path. Same way, since this is the earth and this is the moon, and if the gravity is equal to 0 at this point, suddenly what will happen? It will be moving in the tangential direction. Okay. Calculate the average density of the earth in terms of small g, capital G and R. So we know that density equals mass by volume. Okay, so mass divided by volume of earth is 4 by 3 pi r cube. We need to find out density in terms of G, capital G and R. Okay, in this value, so we should avoid M. How we can avoid M here, and G also, G is required over here also. So here G equals Gm by R square. So in terms of M, we can write it as, so the M we should avoid, right? So M is equal to Gr square divided by capital G. So instead of M, we will be getting Gr square divided by capital G. So density rho equals Gr square divided by capital G into 4 by 3 pi r cube. So r square and r cube will get cancelled. We will get it as 3g divided by 4 pi g. This will be the representation of rho in terms of small g, capital G and r. Which is extra over here, that one we should remove. Okay, so for that only we used small g is required also. So in terms of small g, we can change the value of M and we are getting like this. Clear? So the next one is, the earth is acted upon by gravitation of the sun, and even though it does not fall into the sun, why? Okay, so already in the first question we told that a gravitational force will be balanced with the centripetal force. Since one gravitational force is acting between the sun and the earth, even if it is acting between sun and earth, a centripetal force is acting towards the center. So it will be balanced over there. Okay, clear? Next is, identical packets are dropped from two aeroplanes, one above the equator and the other above the north pole, both at height h. assuming all conditions are identical, will those packets take same time to reach the surface of the earth? Justify your answer. So, two packets are dropping from the two aeroplanes. Okay, one is just above the equator and other is above the north pole. Okay, then we should find out assuming all the conditions, all those packets take time to reach the surface of earth. Will those take same time or not? That only it is asked. So here in that question, see, we know that from two aeroplanes, two packets are dropped. Right, one is from the pole, above the pole, and another is above the equator. Okay, so we know that, see, in the second question we did, S is equal to, it is depending only on the vertical height, isn't it? Since it is dropped, the initial velocity is equal to 0, therefore half gt square. Right, so what is t here? Root of 2s by g. So it is depending on the vertical height as well as g. Now we should think whether g at the pole is equal to g at the equator. What is the formula for finding out g? G equals gm by r square. Right, so if r is increasing, g will decrease. If r is increasing, g will decrease. If radius is decreasing, g will increase. We know that earth is not a perfect sphere. Instead of that, it is more at the equator and less at the poles. This is equator and this is pole. So radius of earth at the equator is more than radius at the pole. Isn't it? So what will be the g? G at the equator is less than the g at the pole. So while we are substituting in this equation, we will get t. G is at the denominator, right? So at the g at the equator is less. That means t at the equator is more than t at the poles. So which will reach first? It is pole will be reaching from the pole which is dropping, that will reach first to the earth, surface of earth. Okay, clear? So this is how we are finding out this one. So the next question is, the weight of any person on the moon is about 1/6 times that on the earth. How can lift a mass of 15 kilogram on earth? He can lift a mass of 15 kilogram on the earth. What will be the maximum mass which can be lifted by the same force applied by the person on the moon? See, weight at moon is equal to 1/6 of weight on earth. Okay, so weight is a factor which is depending on mass and acceleration. Right, so if he can take a mass of 15 kilogram on earth, so on moon how much he can take? He can take 6 times more than this one. Right, because mass on weight on moon is 1/6 of weight on earth. Right, so he can take a weight of 6 into yes, this will be the weight. So mass he can take of 6 into 90 kilogram. Okay, because mass is, if he can take 90 kilogram in moon, how much only it is becoming? 15 kilogram only it is becoming, right? So he can take a mass of 90 kilogram on earth. On moon he can take more mass. Since the acceleration due to gravity is less, weight will be acting less, feeling like less. Okay, clear? So these are the some important questions which is given in the NCERT exemplar textbook. I think all are clear for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.